Okay, picking up with our next example, cosine of 195. Now our formulas are here, so we can either add or subtract. Here's our main degrees on our unit circle. So we'd like to try those if possible. So let's try 195. If I take, let's see, 135 degrees, plus I add 60 degrees to that, that would give me 195. So let's rewrite this with an alpha and a beta, and we're going to do our sum formula. So write this first one down and go ahead and fill it in and evaluate that. Okay, so rewriting, this is my alpha, this is my beta, plugging it into the formula. First thing I want to do is evaluate cosine at 135. So we come to 135, cosine value is going to be negative square root of 2 over 2. Cosine of 60 is 1/2. Sine of 135, we come back over here, the sine value is going to be square root of 2 over 2. Sine at 60 degrees is going to be the square root of 3 over 2. Okay, let's algebraically simplify this. So we would give us a negative square root of 2 over 4. And then minus square root of 6 over 2. Let's take out a negative 1/4 this time since both terms are negative. And we would be left with the square root of 2 plus the square root of 6. Okay, and now we also see an example with a tangent of 165. Likewise, we're trying to find two degrees that will be easy to either add or subtract to give us 165. Well, it looks like it would be easy to do the tangent of 120 degrees plus 45 degrees. Okay, so both of those are on the unit circle. This would be our alpha, this would be our beta. Let's go ahead and plug these in and then evaluate. Okay, so we pulled this alpha plus a beta, we labeled this one our alpha, and we labeled 45 degrees our beta, and we plugged it into our formula. So let's go ahead and start working on calculating this. Tangent at 120. Tangent is your sine over your cosine, so that would be the square root of 3 over 2 over a negative 1/2, which would simplify to a negative square root of 3, plus the tangent at 45 degrees would be square root of 2 over 2 over square root of 2 over 2, which is nice, simplifies to a 1. 1 minus tangent of 120 we said was negative square root of 3. We multiply that by the tangent of 45. Alright, let's just see if this simplifies. Negative square root of 3 plus 1, then in a 1 plus the square root of 3. Alright, now if we didn't want that radical on the bottom, algebraically we could multiply this 1 plus, actually 1 minus the square root of 3 by a binomial factor, 1 minus the square root of 3, so we could get rid of that radical. Well, then we would do the same thing in the top, kind of like a conjugate there. So we'll have this. Now we need to FOIL this out. So let's take our time. So we're going to get square root of 3 times 1 is negative square root of 3. Then we would have negative square root of 3 times square root of 3 would be just a negative 3. Then we're going to have a 1 times a 1. Then we're going to have 1 times a negative square root of 3, which is a negative square root of 3. In the denominator, we'll have 1 times 1 is just 1. We'll have negative square root of 3. Then we're going to have positive square root of 3, so these are going to cancel. That's why we chose to do that. And then this times this is just going to give us negative 3. So basically we'll be left with let me here I have a sign change. Negative square root of 3 times the negative square root of 3 should have been a positive right there. So fix that real quick. Now we want to add like terms. 3 plus 1 is a 4. And then I have minus 1 square root of 3. Minus 1 square root of 3 is minus 2 square roots of 3. And then in the denominator, we'll just have, if this term cancels with this term, I'll have 1 minus 3, which is just going to be a negative 2. And delete that. Okay. Now, if I want to pull out, you can see it, at least a 2 is in this one, this term, and this term. So what if I pull out a negative 1/2 in each of them? So that I can get this 2 out and this negative. So I pull that out front and I'll be left with a 4 in the numerator. And I'll be left with a positive 2 square root of 3. So basically if I distribute this back out, I should get this. Negative 4 square root of 2, and then a negative over a negative is a positive 2 square root of 3. Oops, I mean negative right here. 4 minus. And so make sure you do that right. If it helps you, you can do this. Let's pull this back out. Negative, and then that would be 4 over 2, which is 4 over a negative 2. And then right here would give us a negative times a negative is a positive 2 square root of 3. Where if I did this term over this term, a negative divided by a negative is a positive. So if it helps you to FOIL that out, to just check your sign, it's real easy to make a mistake right there. As you can see, I almost did the same thing. It helps to FOIL it back out to make sure that you have equivalent solutions. Okay, we have a good bit going on with this one. First of all, before we even start, secant is an even function. So let me remind you, an even function. So what that means is secant of negative theta is equal to the secant of theta. So basically this is the same thing as this will give us the same value as the secant of 5 pi over 12. Okay, the other thing is we weren't given some difference formulas for secant, so we can rely on the fact that it's the reciprocal function of cosine and rewrite this. Remember, that's the same thing as the 1 over the cosine of 5 pi over 12, right? Okay, so what we want to do over here to the side is rewrite 5 pi over 12. And we want to have a common denominator of a 12. And we either want to add or subtract to get like radians on our unit circle. That could give us a 5. Well, that's pretty easy. A 3 pi plus a 2 pi. Now if we simplify those, that would give us pi fourths here and pi 6 here. So what we've done is we've figured out an alpha and a beta. Okay. The next thing we want to do is we want to go pull our cosine formulas. Okay, so we pulled the cosine alpha plus beta since we have an alpha plus beta, and then I plugged in pi fourths for alpha and pi 6 for beta. Now let's calculate that. Cosine of pi fourths is just going to be, look at your unit circle, square root of 2 over 2. Cosine of pi 6 is square root of 3 over 2. Sine of pi fourths is square root of 2 over 2. And sine of pi 6 is going to be 1/2. So let's go ahead and simplify this. Square root of 6 over 2 minus the square root of 2 over, actually, over 2 times 2 is 4. Sorry about that. Square root of 2 over 4. If we pulled out a 1/4, it would be a 1/4 square root of 6 minus the square root of 2. Remember, these two are equivalent. This just pulls out a GCF. But this is just the cosine of 5 pi over 12. To evaluate secant, we need to put 1 over that. Okay, now to algebraically simplify, I'm going to multiply by the reciprocal, which would be 4 over the square root of 6 minus the square root of 2. Whatever you do to the denominator, we must do in the numerator as well. So times the reciprocal square root of 6 minus the square root of 2. And then everything in the bottom is going to reduce and simplify. Then that's just going to leave us with our numerator, which that would simplify to 4 over the square root of 6 minus the square root of 2. Now right here, if we want to get rid of these radicals in there, we can still do some more algebra and multiply both sides by the square root of 6 plus the square root of 2. Whatever you do in the denominator, do in the numerator as well. So there's just a lot of algebra simplification in this problem. Okay, if we were to simplify that out, that's just going to give us 4 times the square root of 6 is 4 square root of 6 plus 4 times the square root of 2 is 4 square root of 2. And the denominator will get square root of 6 times the square root of 6, which is just 6. We know that inside terms, that's going to give us square root of 12 minus the square root of 12, so they'll cancel out, and then I'll just have minus 2. So if you need to work that all the way out, you can do that. And that's just going to give us 4 square root of 6 plus 4 square root of 2 over 4. And then what do each of these terms have in them? A 4, and a 4. So let's reduce everything, factor out a 4, divide a 4 out of everything, and we would be left with square root of 6 plus the square root of 2. So let me go back. A lot of work. First of all, we use the fact that this is an even function to just have 5 pi over 12. The second thing, we use our reciprocal properties to rewrite this using cosine. Then we pulled our cosine formulas, evaluate it, and then plug that back into the fraction to then over here do a lot of algebra.